been true 5 or 10 years ago, but it isn't today. We now have much safer than your data center, much more HIPAA compliant than your data center, and much easier to use cloud-based servers within our industry. Google has a set of offerings, our competitors have an offerings. I prefer you choose ours, but choose any over zero, right? You get the idea. Now, why do you do this? The cloud is more secure, and I don't want you repeating the infrastructure work that we're doing. I want you all to focus on the innovation to achieve the vision that I outlined. Now, at the same time, a revolution has been happening in my industry that I want to take you through. And I've been trying to think about how to describe it. And my simplest answer is, scale changes the rules. Scale changes everything. The combination of cloud computing, which you all know what I'm talking about, deep neural networks, which were invented maybe 10 years ago, and some newer algorithms, generally known as reinforcement learning, the explosion of data and so forth have allowed us to do these things. I'll give you an example that you can take a set of labeled data, feed them into one of our systems, which is called AutoML, and it will automatically produce the neural model that gives you the classification that tells you what's in the picture. It's literally just like that. That's how fast this is working. It's obviously more than just for healthcare. In terms of machine learning, which is what the primary progress in the next few years will be about, where does it apply? Medical records, I'll come back to that. Quantitative observations. There's this explosion of data, and I'll talk about that, that enables you to do enormous numbers of interesting things. And applying machine learning, I'll give you an example. Genetic variant calling is a process where we look at DNA and we say what variants are present. We open sourced a tool to do precisely that on this very large amount of genetic data that people are now assembling. Medical imaging, largely a solved problem. It's easy to understand if you remember that computer vision is now better than human vision, even for a perfect human vision. And none of us have perfect human vision, especially at night and when we're tired and all that. So the formula is data plus cloud plus the powerful networks plus deep learning and reinforcement learning. How do we apply that to all of this? And these sort of new, interesting designs that people are developing have profound implications. There are people who are now working on what I would just call reverse random control trials. What they do is they take all the historical data and they look backward, they look at perturbations at the data, and they treat those as randomization events and conclude that a true random trial will produce the outcome that you're looking for. So this sort of new approach to doing experiments has a lot of implications. You take the data that you've generated, and there are new databases. I'll give you an example of something called the Data Biosphere Project, which is trying to collect all of the genetic and essentially epigenetic and other data that we know into one place so that you can apply that into your algorithm. So in order to make this happen, and I'll come back to this, you need something that I'm just going to call a clinical data warehouse. In our world, the simple way to explain it is take all the data, all these diverse data sets, and just throw them in a big database. And we're talking about a big database, even by Google standards. You curate them into and normalize them into something reasonably usable. You take your sort of the vast computing resources that a cloud computing system refines, and you use sophisticated analysis on them with a rich API. So the conclusion you come to, speaking as the computer scientist, not the doctor in the room, is that you need a second tier of data. That the primary data stores, which are very important and will continue to be the EHRs in the medical system, will be supplemented, not supplanted, but supplemented with a second tier that looks a lot like an unstructured database of all of this interesting data that you collect from everywhere. And this is the key architectural point. This, by the way, phenomena has been repeated for the 40 years I've been doing this in enterprise software. So I know it's the path forward because I've seen it in so many other industries. So today, for example, we're very proud to have announced the Google Cloud Healthcare API, which allows you to take all the data out of the existing data stores, which are EHR and other proprietary data stores using FHIR, HL7 version 2, DICOM, a few other protocols, and put them in a normalized way into these new databases. And I'll mention a few classification examples. This is pathology. Relatively straightforward. You take labeled data, you basically train it, and then you show it another picture, and it can say that's a so-and-so. We've had enormous success with ophthalmology and with cardiology, with brain scans, with stroke and analyzing vascular systems, for example. But to me, classification is the easy stuff. Now, it's hard for most people, and we've made it automatic with AutoML. But the really powerful stuff, right at the edge of what I do, is prediction. It's one thing to be able to classify, it's another thing to predict the next step in an outcome. But what I want is prediction, right? Because prediction allows me, or more importantly, a clinician, to intervene earlier. We have physicians inside of our company who believe that if these algorithms for prediction work, we can predict outcomes in the ER, for example, 18 to 24 hours earlier than any other observational system, because the deep analysis that can now be done against the historic data. We'll see if that's true, but I think they're right. So I'll use an example. Shakespeare in Hamlet wrote, "We defy augury," referring to us as humans, saying that we can't predict our own fates, but machines can. That's the point here. To me, that's what I want as I age. I want the computer and all this work I've done in my whole career to be used to make sure that I have a healthy life, or at least a long and healthy life. So going back to when I use my Liz example, when Liz is whispering in the doctor's ear, she has not only access to the best practices, right, for detection. That's this classification that I'm describing. And remember, computer vision better than human vision. But more importantly, she can use new prediction algorithms to generate new life-altering recommendations that will essentially deliver it to me and everyone in this room. Now, how this works is a technology called reinforcement learning. And the simple explanation is that it has a simulator, and it looks at forward outcomes, and it trains to see the optimal outcome. And we've done this successfully in a project called AlphaGo and AlphaZero, which I'm sure you've heard about, where in games, in complicated games, we can do much better than humans in problems that were thought to be unsolvable. We believe that the training data, literally the real-time experience that your clinicians in your institutions, small, medium, and large, we put it all together, and we think we can build reinforcement learning-based solutions that can significantly improve the pathways of care that you all are doing every day. So put another way, a prediction means that the clinician will offer you a prescription ahead of when they normally would have, or a treatment ahead of it because of that. Now, another problem that's happening is that healthcare is becoming essentially an information science. A reasonable estimate is that as a person, as a patient, I have 5 gigabytes of healthcare data around, most of that being images of one kind or another. A lot of people think that there are at least 150,000 observations per day on patients that are just ignored per patient because they're all real time. There's no way to track them and store them and so forth. Can you imagine when we have the combination of sensor data plus continuous behavioral data, which you're going to get from your smartphone, and the various smartwatches that are coming, plus all the molecular data and so forth? This data explosion is profound. So let's look at some areas where we're getting some wins. I was really shocked to discover this. Sudden cardiac death, #1 killer worldwide. There are roughly 5 ways for this to happen to you. We don't want it to happen to you. Almost all of them seem to be predictable, and they're probably delayable, right? By just looking at the sequence of events in a person's life, we can probably intervene one step earlier and get them on the appropriate treatment. This has not been automated at the level that I'm describing. I'll give you another example, automatic reading of ECGs. Hospitals have billions of these ECGs just sitting there, and they've all been classified by humans who've read them. The current ECG approaches are general, and the tools are generally thought by physicians not to be reliable for whatever reason. That's an obvious application for machine learning, vision, and so forth. I'm sure we can do that pretty much near perfectly. I'll give you another example, atrial fibrillation is a situation where you have an increased clotting risk, which can lead to stroke, and it's obviously a very bad thing. So who should be on blood thinner? Well, doctors have this complicated scale. Think of it as everything in medicine seems to be a 5 or 6 point scale. You have this, and if you only have 2, we do this, and if you have 4, we do this. And those were developed over years of experience from the clinicians. But we can do so much better now to determine, and my estimate is that the mortality benefit, if we just put that in one of these systems, and do the proper historical analysis, the mortality benefit in terms of lives saved is probably comparable to a new drug and far, far cheaper. I'll give you another example. I didn't know this. And again, we have doctors in the room. Maybe all of you knew this, but I didn't. That the retina, in particular the fundus, is a view into your vascular system of enormous value. Interesting. So it turns out we just published a paper where we went through and we took retinal images and we accurately predicted heart risk factors more accurately than the doctors in our trial. In particular, age, sex, A1C, blood pressure, etc. What can you imagine a situation where we take that result, which is just the beginning of result, and then somewhere, some hospital runs an appropriate multi-year trial where they actually do retinal images and they train against what the doctors do, so that when you start, right, and the first thing they do is take a retinal image and they say, we see the path of your disease now, and we know exactly when we're going to have to intervene unless you do A, B, or C, right? That's the kind of model that's predictive that's now possible. Now, this technology already works on diabetic retinopathy and macular degeneration. Those are relatively easy, but the power is this predictive capability. Another example is large vessel occlusion in strokes, right? We can now do this in a few minutes for a process that typically takes hours, and there's a startup doing that. Another example, there's a recent study about doctors and how they spend their time, and this is doctors and nurses. The rough answer is that they spend 2 hours of admin time for every 1 hour in front of a patient. No wonder 50% of the physicians report burnout in this situation. I'd feel the same way. That's not what they went to medical school for, did their residency, took on all that debt. They're actually there to serve patients, and instead they're serving the administrative system. And that's what they tell me. So, and by the way, the worst hit ones are the high pressure ones of ER, family, the sort of internal medicine ones, the ones where these decisions are so acute. There's another problem within the hospital community, which I'm just going to call alert fatigue. They've got so many different systems that are not particularly integrated that all these alerts are going on, and it's already a high pressure situation. My God, right? What these people put up with, and how, by the way, how low we pay them, which is a separate discussion. So we can fix that by trying to figure out which alerts lead to good or bad, in this context, outcomes, and automate it. I'll give you another example. It should be possible with insurers at risk to automate and streamline when you see the patient's whole background in all sorts of interesting ways. There's this whole movement to value-based care, which obviously all of us support, and otherwise we're just never going to be able to afford what we're trying to do in healthcare. So, but we're in the Stone Ages now. 80% of the referrals and insurance interactions seem to be by fax, right? Well, that was really exciting in the 1980s when it became popular. Surely we can do better 40 years later with some of this technology. I mean, this is bizarre. How could we allow this? And the reimbursement decisions are made on the phone. I mean, this is what computers were built for, so humans could be doing things that are more powerful and better suited to what we're doing. So the sum of this, right, the reinforcement learning, the deep learning apply to heart disease, cancer, pathology, radiology, imaging, workflow management alerts, the transition to value, it touches everything. So let me do a couple of other examples to illustrate the power of what we can do. The consumerization that's going on is equally large and equally unaccounted for in the data architecture. Consumers, of course, are becoming much more demanding just in general. It is the on-demand generation. But look at it. Telemedicine is increasing. Mobile-based chronic disease management. People want to do that on their phones. Wearables are looking much more like medical devices. And everything is becoming much more user-friendly. Where is all that data going to go, guys? Right? At the moment, it's going to proprietary databases that's not integrated, and we don't get any value from it except for the app that particular vendor did it. That's precisely not how the internet was built. It's not how data networks are built. It's not how data science works. I can go on. The physical footprint of healthcare systems is changing. People are now going to the equivalent of CVS's and Walgreens clinics and so forth. How are we going to get all of that data into this other place? Right? The only way to do that is using the principles of cloud and networks, putting it into these clinical data stores and so forth. And you could imagine an instrument at home. Well, that generates all sorts of data, right? Sleep patterns, right? Behavior patterns, eating patterns, and so forth and so on. So going back to the Liz example, Liz has information not just from what is going on in the medical context, but also has information, again, you've given her permission to do this analysis, around what's happened offline, right, on your phone and in your healthcare situation. Now, I want to emphasize that EHRs are incredibly important here, because EHRs broke through trying to get the data in one place, and they did a great job. So not only are they the revenue engine for the firms, the two large ones, and then a very large number of interesting ones that are serving smaller markets, but the sum of what they did in terms of revenue is crucial, and they also manage the workflow of the institution. Those two functions are going to continue and become more important for all the reasons that I've described. But I also think that Fire and HL7 version 2 development will not fully get the information out of those for various reasons, and that the conclusion that you're going to come to is that you're going to need this mid-tier data store for the reasons that I described. So when I look at this, and I'll finish up in the following way, when I look at this and I say, why is this not happening faster, right? And there's many potential reasons. After all, we've got the technology, there's no question the value of this. We'll probably make some money from this, the startups are getting things, but there's something missing. And I will tell you that in all my years in other industries, there's a lack of the killer app, excuse the pun. There's a lack of something which causes all the data, all the interconnection, and all of these things to become rationalized. My own view, and I'll give you an example. People forget that Windows 95 did not initially have internet networking on it. It was seen as an add-on. In the 1980s, when I first started building email systems, they were seen as an app that was not particularly important and usable occasionally. Before the smartphone came out, every phone had non-integrated systems. The smartphone, which was, again, the killer app, as the internet was and as email was, forced that integration of all the data. Today, it's inconceivable that that was true. But it was true in my lifetime, and I helped build some of those systems that were faulty, so I remember them. The important point is that this transition needs not just one killer app, but another. The transition will go from workflow-based to voice-based. That technology is clearly in hand. But if you think about it, what we want to is we want everybody practicing up to their level of license. We want the patient involved, but we want the doctor working at the doctor level, not at the administrator level. You get the idea. So put it this way, what does it take to make Liz? Well, you need a common digital health data store. You need normalized data from all the sources. We know how to do that. You need longitudinal trend analysis and then the kind of machine learning and reinforcement learning that I described. And the ability to predict next steps. Again, this is technology that exists today in one form or another. You need voice translation, transcription, voice generation, and multi-speaker disambiguation. That work is either done or underway. And you need language recognition good enough to do the text-to-speech and so forth. We're much closer than you think we are to the vision that I outlined. Mm-hmm. This is fundamentally a search problem. And Google is very good at search problems. And I think that all of you together working can provide all of the components that I described. We'll do our part, you guys need to do your part. Now I will tell you right up front to finish, this is really hard, it's really humbling, and it's really complicated. But if we all work together, we can really save lives at a scale that is unimaginable because of the impact of these technologies. And I will make one prediction. So I spoke here a decade ago, and my prediction is that 10 years, if you invite me back, I will bring the equivalent of Liz to join me on stage. Thank you very much.